I'm a boat builder from the Cotswolds in the UK, and I'm currently building a boat called Temptress, designed by Michelle Berrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and epoxy wood construction. I started out by building a quarter scale model version of the boat to prove the process, and that's what you can see behind me here. And now I've started to build the full-size proper boat. In this video, we're going to be taking a look at frame 3. We're going to be building that, and it's all about refinements in this one. So if you saw the last video, we did a 3D CNC carving process of this frame post-assembly. We're going to do the same process on this frame, but I'm going to roll out a whole load of refinements and hopefully improve upon the results that we got in the last one. That is partially down to some of the things that I've thought about since I did the process, but also it's down to you guys and all of the great comments that I had on the previous video. So I really appreciate all of the input that you guys gave, and there are lots of great ideas on there, some of which I have rolled out with this frame, and it's given some really great results, improving upon what we did last time. So we'll take a look at that in this video. First thing we're going to do is jump onto the computer and we'll take a look at nesting the parts to begin CNC cutting the stock for building the frame. Okay, so this is how parts would generally come in with Temptress. So there's DXF files with the plans. So this is what you get from that, and we've got the solid wood parts here. This would be 9mm ply, and then these 3 sheets here are 12mm ply. Now what I'm doing, you might have noticed, is that I'm actually cutting some of the components that would be ply from solid wood. So that's things such as the gussets, and the bulkheads are going to be plywood still. I've got a mix of some parts that are going to be solid wood and some parts that would be ply, but I'm doing them in solid wood as well. So re-nesting is going to be expected here. And the way that I'm doing that is I'm drawing each of my stock boards. So I go out to the shop and I'll measure one of those boards to see what size they are, and you can see here the 2 boards that I've cut already. So then I'll draw a new bit of stock for the next board that I want to cut. Then what I'm going to do is go and pick up the parts that I want. Okay, so there's my parts nested. I've done some holes in here which I'm going to mark with a machine, and those are going to be my clamp points. So hopefully we're going to avoid having a crash that we did last time where I drove into a clamp. So they should indicate to me safe places where I can position those. So I'll do a little marking operation for that. And there's my nested parts. So that's ready to go. I'm going to create some tool paths and then we'll cut some parts. Okay, refinement number 1. So I've used the small tool just to mark a couple of little positions, and I did that without the board clamped down, so they're only tiny little passes. They're not really going to move the board if it's just sat under its own weight. So I've just done that, marked the 4 positions for my clamps on the board, which I've done actually in the toolpath. So I know I'm going to avoid my clamps and not have another crash scenario, which is good stuff. So that's the board loaded up, ready to start running the toolpath on it now. Success. Okay, second batch of parts cut. This works really well. Really nice clearance around all of those, and that's actually quite nice, just having that confidence that you know it's not going to hit anything. It means you can run the tool paths a little bit faster and cut at the speed that the cutter likes to be run at, because these 3 flute compression cutters, they want to be pushed quite hard really, especially if you're running higher RPMs on the machine. You've got to be pushing that cutter through the stock fast enough to stop heat building up. So they do want to run fairly quickly, and that'll then get you a good finish. So yeah, pleased with that. These are actually quite efficient really, material wastage wise. There's very little waste on this. Obviously we've got stuff in between parts, but considering, you know, boat frames are normally incredibly wasteful of timber if you cut them manually, but this is actually doing pretty good, considering that we've got these little fillers and things that we can just fill in gaps with. That really helps a lot, I think. And if we look at the waste from the first board, that's all my scrap that's left, and I'll keep bits like this because we might be able to get some small stuff out of that, whether it's plugs that we need or various other parts. We'll keep them anyway. So yeah, pretty pleased with how the waste factor's looking on these. Okay, so that is all of our plywood bulkheads cut. You can see we've got 2 different types of plywood here. So both of these come from Robbins Timber, and this one is called their Super Elite Ply. So this is a Sapele plywood all the way through, and it comes with a 25-year guarantee on that one. Now, bear in mind that that is before I completely encapsulate this with epoxy, so we're going to actually get a life expectancy way beyond that with these bulkheads. And this is what they call their standard Elite Ply. So this is a Gaboon plywood all the way through, and that comes with a 15-year guarantee. So again, we're going to get a life expectancy well above that. So the Gaboon plywoods are going to be in areas of the boat where there's going to be a veneered face. So places that will be visible within the boat from the cockpit once the boat's finished. And the Super Elite Sapele plywood are going to be things that will be below the sole boards and things like that, a little bit less out of sight. So we'll still get a really nice finish on that, but there's no sense in going to the lengths to veneer those. So what I've actually done with these is I've gone down a thickness on the ply. So this would be a finished 12mm bulkhead. So I've gone for 9mm ply here, and then I'll build up that thickness with the veneer either side. This would be an 18mm bulkhead, and this is 12mm ply. So then I'll go up with the thickness of the veneer either side of that, and the same for the big flat bulkhead on frame 9 that's underneath. So we'll take a quick look in the CAD model and we'll see where these lie within our boat structure. So cross section of our CAD model, you can see here frame 1 that we've done already. So right up forward there, that frame is done with the bulkhead in Super Elite Ply, which is our Sapele ply. And then all of these bulkheads that lie underneath the sole boards here, they're going to be done in our super elite. The ones that I'm going to veneer are going to be ones such as this bulkhead here, which you'll be able to see from within the cockpit. And we've got these apertures within the frames that create a crawl space up into the forward end of the boat. And you can see that's the same with frame 2 there. And they're going to have a little capping that will run around the outside of that crawl space there as well. We've also got frame 9, which is our full bulkhead that creates the seat back for the aft seats and also the engine bay as well. So that's going to be veneered as well, although it's behind the seats. I think it'll still be nice that if you pull the cushions off, you've still got a nice Sapele or Utili veneered face to that. So that's roughly how the bulkheads fall. All of these are going to be super elite, and then the visible ones are going to be thinner gaboon ply with a nice veneer on the face of them. So for that reason, I'm going to jump on to doing frame 3 next. So this is the bulkhead for frame 3. It's one of our solid Sapele ones. And what I'll do in the next video is we'll take a look at frame 2, which is this one here. And we're going to do some additional things. So we're going to be cutting some veneers. We'll be resawing some veneers for the face of this, and we'll vacuum bag it to apply those to the plywood. We'll be doing some timber moldings that run around this aperture here, and a few different things on frame 2. So we'll get onto that further down the line, but right now let's do a dry fit of frame 3 on the construction table. Okay, so if you haven't seen the frame construction table before, this is a board that has holes all the way throughout it, and they correspond to holes that are in our frame parts, and it helps us to position all of these frame components and get a frame glued up that's nice and true and square. And then we've got various other different features that the table does as well, such as giving us the ability to transpose lines through to our frames, like the center line and water lines, that are going to help us to get the frame at the correct height when we put it in the strong back further down the line. So it's a good opportunity to do a dry assembly of the frame and just make sure that everything's working as it should do. So we're going to get frame 3 assembled, dry fitted on the board, and just do a check to make sure that everything's as it should be. Okay, so there we go. You can see how our grain orientation affects our parts here. So this is really nice. We've got the grain running straight through the middle of that part, so we've got maximum strength in the correct plane for that. Then we've got it bridging across our keel filler here, and the same with our keel gusset, which will go over that and tie all of that together. Then you can see we've got a really nice makeup of grain orientations in our chine area. So we've got the side coming down there, and then we've got our grain for our frame bottoms coming up there, and then this chine filler just kind of bridges between the two, and then the same with the chine gusset when that goes on as well. You see we've got a nice 45 between that, so we've got good sort of multi-directional grain in those parts of the boat. It's going to be nice and strong. So you can see this frame's quite a bit bigger than frame 1. We've got quite a big span on this deck beam. That's going to need some rethinking when we get to doing the CNC carving stage. So I'm going to implement some new stuff there, and be really interested to see how that works out. Okay, so there's something interesting and just worth noting here that I've found. So as I'm just putting together frame 3, you can see that there's a slight misalignment of that joint there. So this part has got a dowel in it here that's placed, and that is just apparently due to the fact that the deck beam wants to come down slightly. So if I just pull this down, you can see that joint And then struggling to show you one-handed, but if I then put the dowel in, that's going to pull that joint together, and then that stays in place. So just another kind of feature that this board is doing really is it's forcing these parts into their correct position and kind of confirming that. So there was a time when I thought that perhaps you could build these frames without the construction board and just use this alignment system alone to get you built frames, but I really don't think that would be accurate enough. I think you'd induce errors several different places along the line. So this is quite a big deck beam, this, and there's obviously just a little bit of spring in it, but once it's pinned in place with that dowel at either end, it's then kind of locked into place. So yeah, just a secondary confirmation that it's doing its thing and we're getting really accurate frames assembled here. So that's nice to see. So let's get this glued up and then get on to the carving phase next. So there's a second glue up. Couple of things I've learned and I will definitely implement going forward. So doing just a few more of the little stainless pins through the gussets really helped. Just 4, so it just stopped that filler from sliding outwards when it was glued, which had a little bit happen in the first frame. So those really worked well, and just doing those when it was dry fit as well just helps to sort of positively locate that part, because you just sort of feel it pull into the hole when you put it back on, and all the epoxy's on there and you can't really see what's going on. So that's a nice move. I'd definitely do that. Clamps, I'm really not impressed with these, to be honest. You know, you can see that one's loose, look. These just pop with the tiniest little touch. I can't really do it one-handed, but they're like so delicate that if you just touch them, they pop back open. And I've had quite a few that it just they're almost impossible to set. So I'm not really impressed with them. What I have found though is that these Irwins fit through the holes. If I take the head of the clamp off, they'll go through, and then they clamp from the underside of the table. And you can get a good hold down for the glue up. So I'll definitely be using more of those. That's nice that they've worked out, because you can never have enough clamps, that's for sure. So there we go. That's glued up. We'll revisit it tomorrow. Okay, frame 3 glued up and ready for the next phase. So really pleased with how that's come out. A little bit of cleanup around the joints, it looks really nice. And we've got a bulkhead in place as well. You can see how big this is in comparison to frame 1. There's the frame we did in the previous video versus frame 3. So we've got substantially bigger thing going on here. So that's going to change things a little bit. Some of the refinements that I really could have done with doing on this frame anyway, we're definitely going to have to roll out this because we've got big long runs here. We can't have them unsupported for that machining operation. So we're definitely going to do some changes there. So we're all ready to go. We're ready to get that set up on the machine and approach the next attempt at carving. So we'll have a quick look at the CAD model in the computer and we'll see how I'm going to change things up a little bit and then we'll get going. So here's frame 3. Now this process is all about refinements, so I've rolled out a couple of those for a different way in which I'm going to approach this. So what I've done this time around is I've actually properly modelled the stock. So what you can see we have here is that's what we've got now. So that is our glued up frame. And you can see that everything's square. And then what we've got here is how we're going to end up with our finished part. So you can see that ghosted out part there is what we've got now. And this part here is what we're going to be left with. So that's really clear to actually see what's going on. So you can see here that we're going to finish right along the edge of the frame as it is currently. And that's because I've designed these parts for this to be done manually. So that is your indication for how far to bevel this frame if you're doing this by hand. So that's the edge that I want to come down to. And you can see that on the beveled side, we're just taking that in slightly. Then we're removing a fair bit of material up around here where the shear clamp goes through, and then up here where some of our deck battens are coming through, angled sections and things like that. So that's just going to help me to get a bit more of an accurate simulation when it comes to creating toolpaths and work out what's going on. Things are going to be a little bit different this time around. We'll hopefully get a much better result. So let's chuck that on the machine. Let's try round 2 and see how we can improve things. Okay, further refinements. Here we go, we've got frame 3 set up on the board. So what have I done differently this time? So I've used these fluted dowels to align the frame onto the spoil board. So I drilled the holes in the same way that I did before. And I'm using these. So if you're a long-term viewer of the channel, you might remember these fluted dowels from back in the day when I did the very first revision of this construction board. And I used these to align my frames onto the board. These are really good because they fit tightly into a hole. So because they're fluted, they're actually sort of slightly oversized in the flutes and they press really well into a hole. So you get a really positive alignment. So that's worked really well here. And it also, because they're wood, of course, means if I hit them, it's not going to be the end of the world, because there are some scenarios where there are cutouts in this region here and they get pretty close to that hole. So if it comes to the point that I do actually hit those, it's not going to be the end of the world. So that is a good move. A lot of people mentioned that we could possibly use metal dowels, which would be great as well, but this is just a lot safer, I feel, for in the event that we may have a tool go into them in various places throughout the boat. So those have done my alignment. So I've got one, I don't need one in every hole really, I've just got one on the chines, one on the shear, and then one down here. Done two down here on the keel. And they aligned really nicely. They all located and lined up with the holes that were drilled on the spoil board, so that's a good sign. Now of course these aren't going to offer any sort of hold down, these are just purely location. So hold downs, this is what I've come up with. So I've got a stack of little shims here. We've got some 9mm ones there, and we've got some 12mm. So what I should be able to do by a combination of these is correctly shim wherever I need to. So because we've done this same thing where we've got the height off the bed again, so we've got 9mm gussets here, and then we've got 12mm gussets further down. So I've got a 12mm under this gusset and then a 9mm under that one. So that means that our solid wood timber are a combination of the two up above our spoil board. So wherever I want to clamp this down, I can use the two of those as a shim, or if I want to put a clamp just here, I can just put a 9mm shim underneath it, or if I want to clamp up here, I've already got one, but I can put a 12mm shim underneath it. So that should mean I can create a little packer anywhere around the frame that I might feel that I need a hold down, a bit of extra support to stop the vibration in this whilst it's cutting. Then when it comes to actual hold downs, I've just knocked up these little wooden ones. So we've got a clamping segment there, and then I've got a spacer block. So this is approximately the same height as that. It's a little bit proud, but as long as it's close to it, that's fine. So that's going to sit like that, and then we're going to put our hold down on the top, and then I'll be able to screw that down with a long screw into the spoil board and create a hold down. The good thing with that is that I can just put these pretty much anywhere, and I can obviously place them initially before I start cutting, but if something looks like it's kind of shaking a little bit along the way, I can just chuck an extra one in and put a bit of extra support in there where it's needed. So that's what I've come up with for clamping. We'll run that this time and we'll see how we get on. There are also a couple of ways in which I want to just do some checks before I start to run any tool paths and do some further verification. So the first verification check that I want to do, I've transposed the center line from my construction board onto my frame this time, and I thought that's going to be quite a good quick reference check. So that should in theory strike right through the middle of my origin, which is in the center of my board, same as I did last time. So if we bring the machine to home, and you can see I've got a little V-carving bit in there, so I've got a real clear indication of the center of the cutter. Drive that over to this line, and then we'll drop it down and we'll see what we get. Now you can see there I am about millimetre, maybe 2 millimeters off that line. So that's an indication that we're perhaps a couple of millimeters too far in that direction with reference to the center of this frame and the toolpath. Perhaps we'll go up to the top end and see. Now up here we're quite a bit off. I say quite a bit, that's probably 3 or 4 millimeters, something like that. But we don't really want to be, we'd like to be able to get to the bottom of why that is. Now, I have actually tried this before I videoed it. So I'm cheating a little bit. What I found was that actually this line, I'm not convinced that that is the Drew center. And the way that I came to that conclusion was that I measured from this line across to this edge here, and then I measured from that line across to that edge there, and it was a couple of millimeters out, and this tiny little registration mark that I've done is where I think the true center of the top of that should be. So perhaps that's an error that's been induced in the construction board with transposing that line. Maybe that's not happened quite as accurately as I might have liked. Be nice to get to the bottom of why that is, because things would be really nice to see that absolutely pinpoint. So that's one check that's potentially highlighted a bit of a misalignment there. I've got one other more advanced method that I'm going to do, and that is actually using a program to check the entire perimeter of this part. Okay, so let's take a look at our toolpath types, and I'll do my very best drawing to try and illustrate what's going on with the various stages that we're cutting at the moment. So this is a cross section of the part that we're looking at. So we're cutting this taper, this bevel to our frame. Now the stock that we actually start with is square. So this is where we begin, and this is what we're looking to remove. Now the way that I cut that originally was to use a cove bit. So a cove bit is kind of shaped like this. Nice and neat that is, isn't it? And what that cove bit is going to do is it's going to come down like this, and we're going to do various different passes as it moves further down. And we get this sort of like looped effect. These little ridges all the way down our part here. So this is effectively what we get. So as that cutter comes down, we get all these little looped edges, and we control how fine they are by what we call the step down. So that's how far down that tool will come with each pass. Now with the cove bit, that gives a really nice transition between those. Because of the rounded nose to it, we're going to be cutting sort of on this corner of the bit, but also up this side. Now the problem that created some of my roughness in the last pass was this this excess stock over this side. So what we really want to be doing is just cutting with this side of the cutter and just sort of giving a nice finish to that edge. In fact, what I was actually doing was removing quite a bit of rough stock on the outside here. So the excess removal of that stock was basically just loading that cutter a little bit more than it really wants to be. So the plan on this time is going to be for the same thing. We've got our bevel there. We've got our square stock. Now what I'm going to do this time is what we'd call like a roughing toolpath or a clearance toolpath, and that's going to be using a square cutter. So we'll use a square end mill, and we'll do a roughing toolpath. So what that's going to do is it's going to come down in steps. So what we'll actually end up with is a stepped finish like this. So our stock is then going to come up here, so we'll get a series of little steps, and that will be just slightly away from where our finished bevel actually wants to land. So we'll do that operation first, and that cutter is going to be a lot more rigid, so it's not going to have a problem with removing the excess stock that's on the outside of this as it comes through, and it's going to be away from our finished part. So any chatter that we may get will be out in this vicinity here, and our finished face is going to be much further in. So we'll do that first, and then we'll run the coving bit afterwards. So what we'll actually end up with there will be a part like this, but instead of our stock being this big square section, what we're actually going to have is a handful of little steps up here. So that means that when we then come in with our cove bit again, you can see all the work that that's got to do is just on this one side of the cutter, and as we step down, it's going to kind of alleviate that. And these steps will be much finer than that. They'll only be like probably a millimetre or less than a millimetre, so we'll end up with a really smooth finish, and hopefully we'll alleviate the chatter that we had in our cutter. Combine that with the new hold down system that I've got, and I think we should be doing pretty well. So with regards to one more system, just to check our process, what we've got, I'll do one last drawing. So when I ran this process before, our coving bit came down from the top and slowly worked out. Now I didn't actually know that I was properly aligned with the frame until that coving bit got to the bottom, because that is where our frame is correctly sized still. So I didn't really know that things were right until I got right down here, and we want to be just taking the tiniest little bit off, if maybe even nothing at all actually. I didn't know that till I got to the bottom. What I'm going to do now is I'm going to do a test run with a long bit, which will just jump straight to the end of that process. So we'll use a long bit that comes all the way down, and it's going to run all around my perimeter and just effectively trace the outside of my frame, and that way I'll be able to just check and see whereabouts I am in relation to the frame. I've written that with a 1/2 inch bit, but I'm actually going to run it with a slightly smaller bit, so I should have an even gap all the way around the outside of my part. So all being well, I can run this bit down, I can go all the way around the perimeter of my frame, and I should be able to measure an even gapping here, which is the difference in the size of the tool that I've created the path for, but what I'm actually going to put in the machine. So we're doing a bit of sort of CNC toolpath trickery here really, but this should be a really good reference for me to drive all the way around the outside of that frame and see how I am. I can stop the machine at various different places and I can measure the gapping, and that will be probably my best indication of where we are as a whole with the frame in relation to what the toolpath's going to be. There we go. Apologies for the drawing, I don't do it manually very often. So I've got my tracing toolpath ready to run. I'll bring the machine over. So what I'm going to do is I'm going to run that toolpath, and I'm just going to pause it. So I'm going to run it without the spindle going, and I'm going to pause it at various stages and just take some measurements between this tool and between the outside of the frame. If we've got everything perfectly aligned, we should have around about the same measurement all the way around, but that's in a perfect world. Let's see what we actually get. So that's what we should be looking for. I'm going to measure that gap and just note it down on the frame. We'll carry on. We've got about 4.5 there. It's interesting listening to the stepper motors without the spindle running. I've never actually heard them, the actual sound that they make. Sounds like a bit of an orchestra playing in my workshop. Okay, results were pretty good, to be honest. We've got a slight difference in some places. You can see here we've got a 5mm gap on that side, we've got a 2.5mm gap on that side, which would indicate that our toolpath is a little bit too far this way. That does actually tie up with the center line indifference that I've measured here, which is 2mm that way, so it's roughly matching. Our chines are about the same. We've got 6 here, 4 here, so everything's kind of saying we're 2mm too far that way with the toolpath, but I'm going to be honest, like a 2mm accuracy on something like this, I don't know that you'd ever even be able to measure most parts on a boat to an accuracy within 2mm, so I really don't think actually chasing down those kind of tolerances is really worthwhile. I could just shift the origin a couple of mil, and that's going to just tie things up a little bit better maybe, but I'm pretty satisfied with that. So let's just get on and run the toolpath. I'll do the roughing one first, and then we'll take a look at things. So there we go, that's after the next operation. You can see we've just come in a little bit further now. We've got a bit more of a stepped finish there, so that's looking really good. That leaves us 1.5mm, so we've got to get rid of this stepped finish of course, but then we've got another 1.5mm to come in, which is what our cove cutter will do, and we'll get on to that next. So yeah, I'm really happy with the symmetry, it's looking good. So there's a result of frame 3. I'm really pleased with how that's come out actually. You see the finish that we've got on there is really nice. Good result on pretty much all of the frame. You can see this is really clean here. We have got a couple of little bits of breakout. There's things like this. Well, we've got some little pieces, but if you compare that to what we got on frame 1, where we had kind of big chunks, and then we had that big chatter mark in the middle as well. We've not got any of that. We've got a really good finish along here through the whole height of the frame, so I'm really pleased with that. Yeah, these tiny little bits of breakout. I mean, you've got the tool coming around like this, and it's just as it kind of whips in, it's obviously pulling the grain out. I don't really know of any way to avoid that any further. If anyone's got any suggestions, please feel free to drop them in the comments and let me know what you think for ways we might be able to get around that. It also happened up on the deck beam quite a bit. You know, we're talking just tiny little bits of breakout on the trail edge of those, and I ran a piece of masking tape across here to try and stop that or reduce it a bit, but it's only, I mean, it's a tiny little piece really, it's not too bad, but there we go. So we've got really nice alignment with all of these. You can see that these cutouts in the two-sided operation have all come out really nicely. And that's what we've got up there. So when we join those together, that'll be really good. So that's frame 3 done. That is 2 out of 13 in total that we've got to do. I'm really pleased with the refinements there. The wood dowels really align positively, and I'm really happy with those, so I'm definitely going to stick with that. The hold downs are really good. That just gave us good support of the frame all the way around, so I was pleased with that. What I don't think I'll bother with again is probably doing the kind of tracing toolpath and the checking and testing and things like that. Obviously I'm still getting to grips with this a little bit, so I'm a bit nervous about getting things wrong, but it's kind of proven to me that, you know, these tolerances I'm chasing, we're like 1 millimeter, 2 millimeters here and there, and I just don't think it's really worth trying to chase down a tolerance of less than that, given what I'm doing. Doing this entirely manually by hand, I think you'd be in tolerances much larger than that anyway. So yeah, I'm really pleased with that. I think on all the other frames, I'm just going to drill the spoil board, put those dowels in, and then run the tool paths and have confidence that they're right, because they've been pretty bang on for both of these so far. So yeah, we'll do that next time. I think we'll do a roughing tool path and yeah, pretty much run it the same way that I've just done it. Just want to say a really big thank you to everybody that is supporting the project. So that is Sykes and Robbins Timber, who are both helping me out with the costings for the timber that is needed for this project. That's West System that are helping me out with the epoxy, and Ep4 that are going to help me with the finishes when we get there, and they're a little way off at the moment. Also, everybody on Patreon that's supporting the project, I really appreciate the little bit of extra monthly income that we can generate through there, because I'm essentially self-funding this project. So I'm trying to do this completely off my own back really, and sort of use the bits of revenue from Patreon and from the videos and things like that to make this work. And that's basically taking the place of me actually doing paid work in my shop. So at the moment, I'm around about 2 days a week that I'm able to dedicate to this. So it'd be nice to sort of be able to put an increasing amount of time to that going forward. So anywhere that you guys feel that you would like to support the project, I would greatly appreciate that if you're able to do it. Whether that is signing up to Patreon, there's a couple of extra benefits to that. So you'll get ad-free videos, you'll get early access videos, and then there's various different merch things and extra benefits such as discounts on the website and things like that for various different tiers. If you're interested in that, that'd be great. If I could get a few more people on board, really appreciate that. Failing that, just keep watching the videos and sharing them, because if the videos do well, then everything will start to work. And the last video did really well, or it has done up until now, so I'm really pleased with that. If we can keep that sort of momentum going throughout the rest of the series, then all of this might just work out. So that would be really great to see. So in the next video, as I mentioned, we're going to do frame 2. So we're going to do something a little bit different with that. We're going to do some resawing and some veneering and some vacuum bagging as well, whilst we veneer that bulkhead that's going to be a finished element within the boat. We'll do the trim around the inside of the aperture, and obviously we'll do some more frame building and carving that goes with that as well. So that's what we're doing in the next video. Hope you've enjoyed this one, and I will catch you in the next one when we'll be building frame 2. Cheers guys.